Hi. To master the key part of organic reactions, it's important for you to know what are saturated compounds and what are unsaturated compounds. This helps unlock the whole process of identification of elimination, substitution, and addition reactions. The others will be done on the side: esterification, combustion, thermal cracking. Those ones we have them on their own, but these ones you need to know saturated and unsaturated, and it unlocks everything. So let's start with saturated, the definition. So a compound is said to be saturated if the C atoms it has only have single bonds, so only have single bonds between their C atoms. So those are saturated. What do we have then? We have the alkanes, haloalkanes, and alcohols, all of them being saturated compounds. Now, what are unsaturated compounds? Unsaturated compounds would then have at least one multiple bond between C atoms. That would give us alkenes, which we are going to focus on because that's part of our matric syllabus. They have double bonds, but also alkynes are unsaturated because they have triple bonds. Now, that will then unlock our view of, or our study on reactions, addition, elimination, substitution. We're going to use some sports analogies to make sure that you understand it more clearly. Now let's go into those type of reactions. Now, the first one we're going to deal with is substitution. Let's look at sports side, whether it's netball, rugby, or soccer. Now, we have the issue of when we say substitution, it means that one player goes out, one player comes in. So nobody is playing two positions at the same time. Everybody is still saturated. They are still complete. Now, that's what substitution is. We are going to be moving from any of these ones that are saturated, alkanes, alcohols, and haloalkanes, and you'll see that the product thereof is still saturated. So it can be haloalkane, alkanes, alcohols, so they can be crisscrossing from the different types, but the main thing is you're moving from saturated to unsaturated. That's the key to substitution reactions. We will have different conditions. We will just give them out on the separate notes to this video just to get the full condition of the reactions per reaction and the different names that can be given to them, not very hectically so. So the one that we are going to spend a bit more detail on now is elimination. Now, what does it mean to be eliminated? Eliminated means something goes out and it's completely out. Whatever remains needs to make a plan on how they're going to. So somebody gets a red card, they go out. The team that's remaining is missing, therefore they have to make new connection, a new bond needs to be made so that the team moves on to the new properties that they have. So elimination is about some atoms are going to be removed. Generally, we will have two atoms that are removed side by side so that a double bond is created. Therefore, we are going to be moving from a state of saturation, saturated, and to a state of unsaturated. So when you see that the product is an alkene, you should be knowing that it must have been an elimination reaction, especially when you see also that the reactant was saturated. Now, we are going to look at the different types of eliminations that we have. Number one, when an alkane becomes an alkene, that means that an elimination of H2, two hydrogen atoms, move out so that the carbons form a double bond. So that is called dehydrogenation. That's the special term given to such an elimination. Now, that elimination requires a catalyst called platinum as well as heat to occur because it's not natural for this elimination to take place because saturated is the state at which a compound wishes to be. So it's not easy for it to lose its saturation state. It would rather, or saturated state, it would rather stay that way. Therefore, we force it with a catalyst as well as heat to remove those H's. Also, the next one would be haloalkane. So now with the haloalkanes, the catalyst required there is concentrated base. You can have other bases, but we are going to do concentrated sodium hydroxide. Mainly the sodium hydroxide or the metal hydroxide can be used. Sodium hydroxide needs to be concentrated, and we also need heat because of the same situation we dealt with, that it is not easy to get something saturated to become unsaturated. Heat is required. So now when haloalkanes become alkenes, two different systems can happen. There were two different reactions can happen. Maybe we had a haloalkane with two halogens. That means that the two halogens will be removed so that we have a hydrocarbon alkene. That would mean we have dehalogenation as the special name. Halogens were removed. In the other ones, you might find that there's only one halogen in the compound. Now, in that case, the halogen is removed and another hydrogen is removed in the adjacent carbon to create what we call dehydrohalogenation. Hydrogen, halogen have left. So please pay attention to the products and the reactants and how they were so that you can give us the correct elimination term or type. The last one are the alcohols. Now, an alcohol, to become an alkene, means that definitely OH must go out. But now, if the OH goes out, it will go with an adjacent H, which means that now we have OH and H together. So OH plus H, wait a minute, that's water. So water is actually removed from the compound. Therefore, we call this dehydration reaction because of the removal of the water. So also this one would require a concentrated acid. For this, we would have the concentrated acid that is used together with heat to again make the reaction to move forward. So it's important for us to know the reaction conditions, it's important for us to know the catalyst, and it's important for us to know what are the special types of elimination reactions that we can have. Because some questions, just saying elimination reaction has occurred is enough. But sometimes they say, what is the special type of elimination reaction that has occurred? That is when these ones come in. You need to know them by heart, please. But you can see that it depends on what went out. Hydrogen, dehydrogenation. Hydrogen and halogen, dehydrohalogenation. If both of them are halogens, then halogens have gone out, dehalogenation. If it's water, then we would have dehydration. We know this one. When a person says they are dehydrated, it means they lack water in their body. Therefore, they need to go drink some water, hydration. So the reverse of that would have been hydration, but that's what we're going to look at in the next set. Now we are going to look at addition reactions. So addition reactions are pretty much the reversal of the elimination reactions. Now with those ones, just look at it. When you add something, it means it was never there before. So you're just adding something that was not there and you're not removing anything. So the only way we can do this is that the original reactant has to have been unsaturated. So these occur from unsaturated to saturated. Now remember, I said compounds would wish to just remain in a saturated state. So when they are in an unsaturated state, they are more reactive. Therefore, these types of reactions are generally what we call spontaneous reactions. They can occur on their own without help. However, sometimes we do add some catalyst to just speed up the process there. So the first one, we have alkenes becoming alkanes, which is what we then call hydrogenation, because we would need to add hydrogen to the compound, and that would can get the assistance of platinum as a catalyst. Then we have alkene to alcohol. Remember we said when there's dehydrated systems, we need to hydrate. So to get an alcohol, we need to add water, HOH, that would give us hydration. Then sulfuric acid can also be used as a catalyst for that one. Then the last one, which does not require a catalyst, is the haloalkane formation from alkene. So that is, again, if we are adding two halogens, it's just halogenation. But if we are adding hydrogen and one halogen, that would give us hydrohalogenation, similar to the dehydrohalogenation we had in the elimination process. Now, these are the compounds we have and the main reactions. So as you can see, if you know your saturated and unsaturated, substitution, saturated to saturated, elimination, from our saturated state, we take out things and become unsaturated for that compound. That would be elimination. It requires catalyst quite a lot because it's not a natural occurrence and it's non-spontaneous. In the addition case, then we have the issue of we are going from an unsaturated state to a saturated state. So we would then have a more spontaneous reaction much faster, whereas the elimination is actually quite slow, which is why we really require the catalyst there to just speed it up and get from the saturated to an unsaturated state. So those are the key chemical reactions. We'll look into esterification, then we'll also look into combustion and thermal cracking, which is actually a type of elimination in some way, where you have a long chain alkane or alkyl hydrocarbon beta that is broken up into shorter chains. So to do that, we will need platinum and heat as a catalyst. So that one we call thermal cracking. We will look at it later on. Combustion, the reaction of alkyls with the oxygen.